A robot arm picks up an apple and drops it into a juicer. Another one opens a fridge. A pair of arms folds a t-shirt. None of this is happening in a real kitchen. Every frame is being generated in real time by an AI model that is predicting what a physical scene should look like, one frame at a time, 50 milliseconds apart. This is Odyssey. On June 17th, the company raised $310 million at a $1.45 billion valuation. Amazon is in. So are GV, AMD Ventures, EQT, and In-Q-Tel, the venture arm of the U.S. intelligence community. The bet is that the next big layer of AI will be a model that understands how the physical world moves, not only how words or images look. Odyssey was founded in 2023 by Oliver Cameron and Jeff Hawke. Cameron co-founded Voyage, an autonomous vehicle startup that Cruise acquired. Hawke came from Wave, another self-driving research lab. They did not start another self-driving company. They started building the layer underneath it, a general-purpose model that can simulate how physical environments change when something acts inside them. Here is the difference. A language model predicts the next word. A video generator gives you a fixed clip. A world model takes an action, like a steering input or a robot command, predicts the next moment in the scene, then does it again after the next action. It runs in a loop, frame by frame, reacting to whatever you do. Odyssey has been shipping models fast. Odyssey-2, released last October, streams generated scenes at roughly 20 frames per second. The company says most video models take 1 to 2 minutes to produce about 5 seconds of footage. Odyssey-2 generates continuously, in real time, while responding to user input. In April, they released Odyssey-2 Max, roughly 3 times the size, trained with 10 times the compute. Odyssey says it scores higher on physics benchmarks for object permanence, gravity, and collision. Treat those numbers as company-reported signals, not independent proof. Then things got stranger. In May, Odyssey released Starchild 1. It generates synchronized video and audio at the same time, and it can respond to text prompts while the scene is already running. You type a command, and the simulated world reacts. The same month, they released Agora 1. Up to 4 players share one generated world in real time. The model keeps track of shared state, so all 4 players see a consistent environment, while each player gets a separate rendered view. The demo looks like an old split-screen deathmatch, generated frame by frame. Underneath all of this is PROWL, an adversarial training loop. Odyssey sends a reinforcement learning agent into game environments with one job: break the world model. Find the angles where geometry falls apart, where objects pass through each other, where physics stops making sense. Every failure becomes new training data. Now, the Amazon piece. Amazon is not only writing a check. AWS is Odyssey's preferred cloud provider, and Odyssey is optimizing its models to run on Trainium, Amazon's custom AI chip. Amazon says Odyssey hit 80% model flop utilization on Trainium 3. For context, Amazon describes the well-optimized industry range as 40 to 50%. That is an Amazon reported number, not an independent benchmark. If it holds, it means Trainium is competitive for this kind of sustained simulation workload. So what is the honest picture? The demos are real, and they are impressive. Real-time interactive world simulation from a pure AI model with no game engine underneath barely existed 2 years ago. But there are limits. The benchmarks are self-reported. Running these models at scale is expensive. One published estimate put the cost around $2 to $4 per user per hour on high-end chips. The physics looks plausible in short demos, but nobody has publicly proven that a robot trained inside an Odyssey simulation transfers reliably to the real world. And the training data, how much is proprietary camera footage versus licensed content versus web video, is still mostly opaque. Odyssey is making a specific claim about what the next useful foundation model looks like. A system that can rehearse the physical world fast enough that a robot, a car, or a game can learn inside it. $310 million says some serious people believe them. Whether the physics actually holds when it matters is the question the demos cannot answer yet.